Section 1.8 is all about graphing functions. In the last section, we talked about what makes something a function, and in this section, what we're going to look at is how we can represent functions by graphing them. So to start, let's look at what you do when you're given a table of values for your function. So in the first column, we have the input. In the second column, we have the output. Now remember, the input represents your independent variable, which we typically represent with the letter X. And the output represents your dependent variable, which we typically represent with Y. So if we look at this, if the input is 1, the output is 2, the input is 2, the output is 3, and if the input is 4, the output is 5. So we can change our input-output table into ordered pairs. So instead of input 1, output 2, we just say we have an ordered pair, 1, 2, and 2, 3, and 4, 5. So then what we'll do is just take that list of ordered pairs and graph them on a coordinate plane. So remember, we just go, if it's 1, 2, that means I'm going to go to the right 1 and up 2. At 2, 3, I go to the right 2 and up 3. At 4, 5, I go to the right 4 and up 5. So here's a graph that represents that function that we were given in the table. And just as a little review, remember the horizontal axis of a graph is always labeled with the input, and the vertical axis of a graph is always labeled with the output. So in our case, it was the x-axis represented the input and the y-axis represented the output. In example number 1, we're going to look at how to graph a function. I've given you a list of steps to use in order to graph a function. First, you need to be given the function itself, which remember, we're going to call that the function rule, which is just a fancy way to say it's the equation that represents the function. So step 1 would be to take that function rule, the equation, and set up an XY chart. Next, you would use the given domain, which remember, those are your X values. The domain is your X values or your inputs. And then using that XY chart, you'll then use that function rule to find your Y values. And remember, your Y values are always your range. So remember, domain is the X values, your range is your Y values. And here's just a little reminder that all points are listed X, Y. So your input and then your output. X values tell you to move left if the number is negative. So again, this is just a review. And you would move right if your X value is positive. The Y value tells you to move down if the number is negative. And you would move up if the number is positive. And just a reminder, this is just a review. And before we move on, let's just look at our steps one more time. Remember, first we're going to set up an XY chart using our given domain values, and then we'll use the function rule, so the equation that we're given, in order to find our Y values, which will then be our range. So let's actually graph this function. So the problem is graph the function y equals 2x minus 3 with a domain of 2, 3, 4, and 5. So again, this is my function rule. Remember, a function rule is just an equation. And I'm going to use that equation with the given domain in order to find our Y values, which is our range. So first, just like the step said, I'm going to set up an XY chart, which I set mine up horizontally. You could do yours vertically. So let's first fill in the X column with our domains. So here we're going to put 2, 3, 4, and 5. And again, those are the numbers that I'm going to put into our function rule, y equals 2x minus 3, in order to find our Y values. As part of our XY chart, I've provided a middle column in order to do some work. So when I put these numbers 2, 3, 4, and 5 into our function rule, that's where I'm going to write my work. So putting the 2 in for the X, I have 2 times 2 minus 3. 2 times 2 is 4, minus 3 is 1. So our output for 2 was 1. Next, we'll put 3 in for X. So we put 2 times 3 minus 3. 2 times 3 is 6. 6 minus 3 is 3. So our output for the input of 3 was also 3. And then I put 2 times 4 minus 3. 2 times 4 is 8. 8 minus 3 is 5. So our input is 4, output is 5. 2 times 5 minus 3. 2 times 5 is 10, minus 3 is 7. Input is 5, output is 7. So remember, the purpose of making this XY chart was to give us a set of ordered pairs that we could graph. So our ordered pairs are 2, 1, 3, comma 3, 4, comma 5, and 5, comma 7. So now I'm going to take these ordered pairs and graph them. So now taking our ordered pairs, I will count out where all these ordered pairs end up being. So for the first one, 2, comma 1, I'm going to go to the right 2 and up 1. Next, I will plot 3, comma 3. So I'll go to the right 3, 1, 2, 3, and up 3, 1, 2, 3. Next, I'll plot 4, 5. So I'm going to go to the right 1, 2, 3, 4, and up 1, 2, 3, 4, 5. And finally, I'll plot 5, 7, so to the right, 1, 2, 3, 4, 5, and up 1, 2, 3, 4, 5, 6, 7. And typically you would take those dots and connect them with a nice straight line representing our function with a domain of 2, 3, 4, and 5 and a range of 1, 3, 5, and 7. Example 2 has us doing the opposite of what we did in example 1. In example 1, we were given the function rule and asked to graph it. In example 2, we're given the graph and asked to find the function rule. Here's the steps involved in order to do so. Step 1 would be to first either make a table of values or an XY chart from the graph, or you could just list the ordered pairs. So let's do that first for the graph that we're given. Here is our XY chart, and let's start listing our values. So if we look, our first point is sitting here right on the x-axis. They're counting over 1 but then up 0. So we would have a point at 1, 0. Our next point would be counting to the right, 1, 2, 3, and up 2. So our ordered pair would be 3, comma 2. Our next point, we would count to the right 1, 2, 3, 4, 5, and up 1, 2, 3, 4. So it would be 5, comma 4. And our last point would be at 1, 2, 3, 4, 5, 6, 7, and up 1, 2, 3, 4, 5, 6. So 7, comma 6. So now that we have those listed, let's move on to step 2. It says to look for a pattern. So when I look at this, I look at my inputs and I look at my outputs and seeing how would I get from this input to this output? How do I get from this input to that output? And so on and so forth. So when I look at this particular function, I see that if I start at 1, I went down to 0. I start at 3, I went down to 2. Start at 5 and down to 4, and start at 7 and go down to 6. So in this case, we took each of our inputs, we subtracted 1 and got our output. So 1 minus 1 is 0, 3 minus 1 is 2, 5 minus 1 is 4, 7 minus 1 is 6. So if we started off with any x value, we would subtract 1 from it to get our y value. So our function rule would be any y value would be equal to taking whatever the x value is and subtracting 1. The domain and the range of the function, as it's stated in this problem, would be the x values and the y values. So remember, the domain, we're always talking about a set of numbers, so we use like the fancy parentheses, the braces. So we would just list our x values, 1, 3, 5, 7. And then our range, we would list the y values, 0, 2, 4, and 6. And again, we're talking about a set of numbers, so we use the fancy looking parentheses, which are called braces. Make sure you write down any notes, any questions that you can bring to class the next day so that we can go over these before you're expected to do your homework assignment over this section. See you then.